Next topic is dynamic equilibrium. Before starting about dynamic equilibrium, I will discuss one point regarding equilibrium, that is equilibrium reactions never goes to completion. That means every time those reactions takes place continuously. Which reactions? Equilibrium reactions, because in equilibrium reactions both forward reaction and backward reaction takes place continuously. Next, coming to dynamic equilibrium, the equilibrium which takes place continuously with equal rates is called dynamic equilibrium. The equilibrium which takes place continuously with equal rates is called dynamic equilibrium. That means what? Dynamic equilibrium, it should be done continuously. That reaction should be done continuously with equal rates. That is called dynamic equilibrium. Next, active mass. Active mass means if a substance concentration expressed in moles per liter is called active mass. If a substance concentration is expressed in moles and liters is called active mass. The concentration of a substance is expressed in moles per liter is called active mass. Active mass of any solid is how much? 1. Active mass of pure liquids is 1. Active mass of any gas at STP is 1 by 22.4. I repeat these points, listen carefully. Active mass of any solid, if you take any solid means either pure solid or impure solid, then its active mass is 1. But in case of liquids, when the liquids are in pure, then only its active mass is 1, otherwise it will not be 1. Next, active mass of 1 mole of any gas, 1 mole of any gas, 1 mole of any gas at STP is how much? 1 by 22.4. Why it will be 1 by 22.4? Active mass is what? Moles per liter. 1 mole, 1 by, what is the volume of 1 mole of gas at STP? 22.4. So finally this will be what? Active mass. So what we have to remember here, active mass is what? Concentration that should be expressed in moles per liters. Its value is 1 when you take any solid. Its value is 1 when you take pure liquid. Its value is 1 by 22.4 when you take 1 mole of gas at STP. 1 mole of gas at STP. Suppose, see, you may get such type of questions. What is the active mass of 32 grams of SO2? What is the active mass of 32 grams of SO2? What is the formula? Moles per liters. That means N by L. N means what? Number of moles, means weight by gram molecular weight into 1 by liters. Weight is how much? 32 by 64 into 1 by liters. 1 by 2. Suppose if it is in 1 liter, then you have to put 1 here. Then half. What is the meaning of this half? Active mass of 32 grams of SO2 value is how much? 1 by 2, nothing but 0.5. Suppose when it is in 1 liter. Like that we have to calculate. Next one. One more point is there regarding active mass, that is active mass of liquids is 1 when they are in heterogeneous equilibrium. Active, here what I discussed, active mass of pure liquids is 1. Here active mass of liquids is also 1 when those liquids are present in heterogeneous equilibrium. What is the meaning of heterogeneous equilibrium? If different physical states are present in a chemical equilibrium reaction, that is called heterogeneous chemical equilibrium. When liquids are present in heterogeneous chemical equilibrium, then active mass of that liquid is how much? 1. So these are the conditions of active mass. You have to remember the points. Next one. Rate of reaction. This is very important point. One of the important definition. What is the definition of rate of reaction? The decrease in concentration of reactants. ORR, increase in concentration of products with time during a reaction is called rate of reaction. I repeat this point. The decrease in concentration of reactants or increase in concentration of products with time during a reaction is called rate of reaction. See, I will discuss the point here. See, suppose I take one reaction. In that reaction, A is reactant, B is product. What is the meaning of this reaction? Here arrow mark is present. This arrow mark present right side. That means what? A is converted into B. Before starting this reaction, we have only A. We don't have B before starting reaction. That means before starting reaction, concentration of B is how much? 0. We have only concentration of A. After starting reaction, this concentration A slightly reduces because it is converting into B. That means concentration of A decreases, concentration of B increases with time during reaction. During reaction means when reaction is going on. After completing reaction, concentration of A will be 0. We have only concentration of B. Then what about rate of reaction? During reaction, concentration of A decreases, concentration of B increases with time. That is called rate of reaction. I repeat this example, listen carefully. Let us assume I take one reaction. In that reaction, A is reactant, B is product. This arrow mark indicates what? A is converted into B. Before starting reaction, we have only A. We don't have B before starting reaction, because before starting reaction we have reactants only, we will not have products. When reaction is started, the concentration of A slightly decreases and concentration of B slightly increases when reaction is started. After completing the reaction, the concentration of A completely becomes 0, because after completing the reaction we will not have reactants at all. We will have only products, so that the concentration of A will be 0 and concentration of B will be high. Then what about rate of reaction? This is second step. This step is called rate of reaction. That means during reaction, concentration of A slightly decreases, concentration of B slightly increases with the time. That is called rate of reaction. I hope you understand it clearly. Here one graph is there to represent concentration of reactants versus time and concentration of products versus time. See, this is the graph which is drawn between concentration of reactants versus time. This is the graph which is drawn between concentration of products versus time. What happened during concentration of during reaction when we draw graph drawn between concentration of reactants in time? What happened? The concentration of reactants decreases with the time, but concentration of products increases with time. See, this graph indicates decreases. Here this graph indicates increases. That means with the time concentration of products increases. Here with the time concentration of reactants decreases. This is reciprocal graph. This is directly proportional graph. Directly proportional means when time increases, concentration of products also increases. When time increases, concentration of reactants decreases. This graph represents, these two graphs represents concentration of reactants and concentration of products with time. Next one more definition is there, that is law of mass action. Law of mass action. The rate of any chemical reaction is directly proportional to product of concentration of reactants and rise to power of their coefficients. What is the definition? The rate of any chemical reaction is directly proportional to product of concentration of reactants and rise to power of their coefficients. That is called law of mass action. Suppose if you take any reaction, any reaction means a forward reaction or backward reaction or reversible reaction. In any reaction, the rate of chemical reaction is directly proportional to product of concentration of reactants and rise to power of their coefficients. Suppose, see, this is the reaction. Suppose I take this reaction again. This is forward reaction. In this reaction, A is reactant, B is product. According to law of mass action, the rate of this chemical reaction is directly proportional to concentration of A. That means what? When concentration of A, that means when the amount of A increases, automatically rate of reaction increases. That is the meaning of that point. Suppose I take two reactants. A plus B gives rise to C plus D. A and B are reactants, C and D are products. This is also irreversible reaction, nothing but forward reaction here. Here the rate is directly proportional to concentration of A into concentration of B. This is called product. So this is the expression for law of mass action. What is the expression? In any chemical reaction, the rate of reaction is directly proportional to product of concentration of reactants. Product means this product, not these products. Product means between A and B, multiplication should be there. Product of concentration of reactant. If any coefficients are there, between before A and B, those coefficients comes here. Suppose 2A plus B gives rise to C plus D. Suppose this reaction is there. What is the rate? Rate is proportional to A concentration of A square into concentration of B. This is called rate expression for this reaction. Suppose here 3 is there, then that 3 comes here. That means in power. That is about law of mass action. So what is the statement of law of mass action? The rate of any chemical reaction is directly proportional to product of concentration of reactants and rise to power of their coefficients. Next, one more point. Law of mass action is applicable to irreversible reaction, reversible reaction, but not applicable to physical equilibrium. This is also one of the important points. This law of mass action is applicable to all reactions except to physical equilibrium. What is the meaning of physical equilibrium? In that physical equilibrium, chemical composition of reactants and products should be same, but physical states must be changed. What is the example? H2O solid gives rise to H2O liquid at 0 degrees centigrade. This is discussed in case of physical equilibrium. If you see this example here, both reactants, products, chemical formula is same, but physical states are different. But physical, in case of physical equilibriums, law of mass action is not applicable. Why? Because see, what is law of mass action? Rate of reaction is directly proportional to concentration of reactions. That means in this reaction, this rate of reaction is not depending on solid state of ice. Why? If you take 10 grams of ice, if you take 100 grams of ice, I took two examples. In first example, I take 10 grams of ice. In second example, I take 100 grams of ice. If you take either 10 grams of ice or 100 grams of ice is converted into vapor at 0 degrees centigrade in both cases, because ice is converted into liquid state at this temperature. That means here amounts are different, but temperature is same. That means what you have to understand in this example, The rate is not depending on amount. Amount is nothing but what? Concentration. Concentration means what? Moles per liter. Moles means what? Weight by molecular weight. In this examples, this constant rate of reaction is not depending on amount. That is why law of mass action is not applicable to physical equilibrium. I hope you understand it very well. This is about rate of reaction, law of mass action, dynamic equilibrium. There are some more topics. We will discuss those topics in next video. Thank you.